Australia once built a steel fence more than 5,600 kilometers long, cutting entirely across the continent from the northern coast of Western Australia all the way down to the south. This is nearly twice the length of the US-Mexico border barrier, which spans about 3,145 kilometers. But strangely enough, this structure wasn't built to stop wars, terrorism, or immigrants. Its sole purpose was to halt the sweep of invasive species, devastating and swallowing an entire continent. In the early 20th century, specifically between 1901 and 1907, to erect this transcontinental wall, thousands of laborers had to work entirely by hand in deserts where temperatures reached 50 degrees Celsius, relying on camel trains to transport materials through places with almost no roads. Yet those brutal challenges were only the beginning. The question is, what kind of creature possessed such terrifying power to force Australia to do this? And what ingenious engineering structures lie behind this colossal wall? We will explore all the details in today's video. Before we begin, don't forget to leave a like to support the channel, my friends. And now, let's get started. The story begins with a seemingly harmless decision, but it sparked one of the worst ecological disasters in human history. On Christmas Day in 1859, at an estate in Victoria, a British immigrant named Thomas Austin released 24 wild rabbits into nature with a simple purpose: to serve his familiar hunting hobby. Austin once claimed that the appearance of a few rabbits could not cause any harm, and on the contrary, would bring a little taste of home. But he was completely wrong. Australia at that time was a completely isolated land, where the native ecosystem had no presence of natural predators to control rodents. In addition, favorable climate conditions and vast grasslands full of food turned this place into a perfect paradise for rabbits to multiply. With no natural predators to control them, their reproduction speed far exceeded all natural limits. Within just a few decades, from the initial 24 individuals, their population exploded exponentially. By 1920, an estimated 10 billion rabbits were swarming across the Australian continent. The resulting consequence was widespread devastation. Billions of rabbits thoroughly chewed up all vegetation in their path. They ate everything from fresh grass and roots to the bark of large trees, causing the land to lose its natural protective layer and quickly suffer severe erosion. Lush green grasslands were turned into dry, barren deserts one by one. Australia's agriculture and livestock industry immediately fell into crisis, suffering estimated losses of up to 200 million Australian dollars per year, a huge sum at that time. The entire national economy stood on the brink of total collapse before a tiny enemy. Before having to consider building a giant transcontinental steel wall, the Australian government and people tried every possible manual solution. They organized large-scale hunting teams, set thousands of steel traps on the grasslands, and even used chemicals and filled up their burrows. Millions of individuals were eliminated through each campaign. However, all those efforts quickly sank into a deadlock. The lightning-fast reproduction rate of rabbits completely defeated traditional control methods. Every time one layer of rabbits was stopped, a new generation with overwhelming numbers immediately appeared, filling every gap. Manual methods proved completely powerless against a biological problem of continental scale. Realizing that humans could not simply use manual labor to completely solve the problem, the Australian government was forced to shift to a milestone strategy of a larger scale, building giant physical barriers to block their expansion. In 1901, surveyor Alfred Canning mapped out the historic route cutting across the interior of Western Australia. By 1907, the first fence was officially completed with a record length of 1,834 kilometers. To design a durable structure in the heart of the desert, engineers had to solve extremely strict structural problems: foundation structure and wire mesh. The fence was not only strung above ground, but it was also buried deep into the ground from 15 to 30 centimeters. The bottom part of the wire mesh was bent outward to form an underground right angle, which completely eliminated the rabbit's ability to dig and tunnel through. Support posts and frame systems. Engineers used native timber posts with extremely high durability against termites and dry climates, combined with reinforced steel posts placed at standard distances. Barbed wire systems and specialized small mesh wire netting were tightly stretched to resist impact pressure from desert storms and animals. Strategic height. The wire mesh section rose about 1.2 meters above the ground, high enough to prevent rabbits from jumping over, while optimizing the volume of transported materials. Extreme logistics challenges. To transport thousands of tons of steel posts, rolls of wire mesh, and material supplies to areas without roads, the construction team had to work entirely by hand under a scorching heat reaching nearly 50 degrees Celsius. Natural water sources were so scarce that horses and pack mules collapsed along the way, forcing the project to mobilize camel caravans to transport drinking water and materials through completely isolated wilderness areas. Due to the rapid spread, a large number of rabbits still managed to slip through weak points before completion. The government continued to approve the construction of fences number 2 and 3, raising the total length of the anti-rabbit defense network to over 3,200 kilometers. When the anti-rabbit system was just shaped, a new technical problem arose. Wild dingoes tried to bite and tear the thin mesh to attack sheep. Engineers were forced to comprehensively upgrade the mechanical structure. Superior technical standards. The dingo fence was designed to be much sturdier, reaching a height of up to 1.8 meters. Specialized materials. Instead of regular wire netting, the project used heavy-duty specialized wire mesh layers with extremely high load-bearing durability, combined with burying the base deep into the ground to prevent digging. Integration of modern technology. At many critical sections today, electric fence systems are integrated to provide supplementary power for the absolute prevention of large predators. This megaproject did not stay in the past. In 2020, South Australia continued to pour 29 million Australian dollars to reconstruct and completely replace 1,600 kilometers of old, worn-out fencing after decades of enduring harsh desert weather, maintaining one of the longest mechanical defense systems in human history, 5,614 kilometers. Although it successfully solved the urgent economic problem, typified by the solid protection of the livestock industry, valued at about 4.3 billion Australian dollars in South Australia, this transcontinental fence system also triggered complex ecological consequences. When humans erected a continental-scale mechanical barrier, the natural food chain began to fracture and create chain reactions. Explosion of secondary species. Controlling dingoes on one side of the fence seriously unbalanced the ecological structure. Kangaroo numbers soared out of control, unintentionally continuing to pressure and destroy vegetation just like rabbits. Pressure on native wildlife. Habitat disruption created favorable conditions for species like foxes and feral cats to thrive, directly threatening the survival of many of Australia's exclusive marsupials and native birds. Landscape changes from space. The impact scale of this barrier system was so massive that the differences in vegetation and landscape between the two sides of the fence can be clearly observed from satellites in outer space. The painful lessons from history forced Australia to completely change its environmental management mindset. Instead of continuing to maintain the mindset of expanding endless giant steel walls, the modern strategy shifted to establishing small-scale, strictly controlled fenced sanctuaries. Here, efforts focused on completely removing invasive animals while restoring and re-releasing native species back to their proper habitats. This project leaves behind a core rule. Nature is a closely connected network. Every crude mechanical human intervention leaves profound chain reactions that no technical blueprint can fully foresee. Thank you for joining us on this journey to break down this mega project. Don't forget to hit subscribe and turn on notifications so you won't miss our next technical analysis videos.